So this video should be really quick. We're going to be looking at finding the minimum or maximum of a quadratic function. And I've already mentioned this before. I've talked about it. I've kind of mentioned it in passing, but I didn't explicitly go over it. So I think it would be good to do that now. So if we want to find the minimum or maximum of a quadratic function, what we do is we just find the vertex. And the only thing I haven't really discussed is how to find out whether or not it's a minimum or maximum if you don't end up graphing it. Okay, if you don't have the time to graph it, you just need to know if the function has a minimum or a maximum. How would you do that? By just looking at the equation. Well, let's go ahead and do that now. So like I've said before, our first step here is to find the vertex. Let's take a look at this first example. We have 3x squared minus 30x plus 79. Okay, so to do this, we're going to find the x component of our vertex. And the x component of our vertex, remember, again, is given by x is equal to negative b over 2 times a. So for this one, it's going to be negative 30 over 2 times 3. Negative 30, that's positive. That's positive 30. So we'll have 30 over 2 times 3 is 6. And 30 divided by 6 is 5. So we know the x component of our vertex is 5. Okay, so to find the y component, I guess these should all be y equals. Okay, for the y component here, we'll have y is equal to 3 times 5 squared minus 30 times 5 plus 79. Or we'll have 3 times 25 minus 30 times 5, that'll be 150, plus 79. All right, so we'll have 75 minus 150 plus 79. Okay, that will give us 4. So our vertex is given by the point 5, 4. Okay, so that means that is either a minimum or a maximum of this function. And so really all we have to do is we have to think, does the function open up or down? Okay, so if the function opens down, then you have a maximum. If the function opens up, then you have a minimum. Okay, so up, obviously you'd have a minimum. Down, obviously you would have a maximum. Okay, and this would be maximum. And this is determined by the sign of your leading coefficient. So in this case, that would be 3. Okay, if it's positive, the function opens up. If it's negative, the function opens, it opens down. Therefore, since we have a positive leading coefficient, that means our vertex 5, 4 is going to be it means it's going to open up. That means it's going to be a minimum. Okay, so there we go. So our function is going to have roughly this shape right here. Let's take a look at this one. Here we have negative 3x squared minus 12x minus 13. So to find the x component, remember it's x is equal to negative b over 2a. Or we have negative times negative 12 over 2 times a. Or in this case, we have negative 3. Okay? So negative 12, that's positive 12. And over here we have 2 times negative 3. So that'll be negative 6. And 12 divided by negative 6 is the same thing as negative 2. So that means that the x component of our vertex is negative 2. So the y component is going to be given by negative 3 times negative 2 squared minus 12 times negative 2 minus 13, or we have negative 3 times 4 plus 24 minus 13, or we could see this as negative 12 plus 24 minus 13. And that's going to be negative 1. So our vertex is given by negative 2, negative 1. And we look at our leading coefficient to determine if it's a maximum or minimum. Our leading coefficient is going to be negative 3. And since it's negative, that means that we are going to have the graph opening down. It's going to look like this. And that means our vertex is going to be right here, and we can see that this is going to be a maximum. Therefore, our vertex is a maximum. Okay, let's do one more. Here we have negative 2x squared plus 12x minus 14. So our vertex, to find our vertex, we have I guess I should just say the x component of our vertex. X is going to be negative b over 2a. Okay, or we have negative 12 over 2 times negative 2. All right, or this is going to be negative 12 over negative 4, or we can just think of this as positive 3. These negatives are going to cancel, and then we have just 12 over 4, which is 3. So the x component of our vertex is 3. So we could plug 3 in for x to find the y component of our vertex. So we'll have negative 2 times 3 squared plus 12 times 3 minus 14. Or we have negative 2 times 9 plus 36 minus 14. Or we get negative 18 plus 36 minus 14, and that will give us 4. So our vertex is going to be the point 3, 4. Okay? And what this means, or I guess now what we have to do is we have to determine if this is a minimum or a maximum. So again, to determine if it's a minimum or a maximum, we look at this leading coefficient, which is negative 2. And since it's negative, that means, again, that our graph is going to open down. And our vertex given by 3, 4 is going to be a maximum. All right.